Hello, geometry students. Welcome back to another unit for geometry. So we're going to start this whole new unit on a thing called rigid motion. And we'll explain that as we go along. But rigid motion begins with a concept called translations, and that's what this lesson is all about. So look at all the things we're going to learn. We're going to learn about naming images and corresponding parts, finding the image of a translation, writing translation rules and compositions of translations. We're going to do all of that right about now. But to begin, we're going to start with a neat little activity. So here's the activity. We're going to suppose that we have letters shown on squares here on tracing paper. So we're going to imagine that we can see the shapes on both sides. And then for each pair of words, how is it that we're going to move those squares around to make the word in B? So we have this word A. How can we do that in word B? So if we look at this first tag, how do we make this H into this I? You know what we have to do? We have to rotate that H 90 degrees to the right. So we can say we'll rotate that 90 degrees to the right. So if we were to rotate that H, we'd have this. How do we make the U into a C? You know what? The same exact way. If we were to rotate that C 90 degrees to the right, we would get, or rotate the U 90 degrees to the right, we get a C. And then what's the deal with the M? So what would happen this way? How do we make this M into this sigma looking thing? What if we went 90 degrees to the left? Okay, so that's how we would rotate those. And we are if you want to do this at home, get tracing paper. It's nice and fun. Now what's going to go on with this letter lowercase b to this letter P? What would happen here? You know, if we flip that B, if we flip it all the way over this way, up or down, right, then we'd end up with a P here. That's how that would happen. How would we get this O to be up there? Same thing. What if we rotate it 180 degrees in either directions? Because flipping it is not going to work, right? What if we rotate it 180 degrees? Because notice how the O is in the bottom corner here and then in the top corner there. Flipping it would put the O in this corner. It's not. So if we rotate it 180 degrees either way, it doesn't matter right or left, because no matter what you rotate it 180 degrees, it's going to end up in the same position. And then lastly, this other letter. So what would happen here with the B to the D? It'd be the same thing, another 180 degree rotation. So notice the difference between rotating and flipping, right? So you can play around with that at home. And then lastly, this letter. How do we go from this letter to this letter, the Z to the N? You know, if we rotate that N, or rotate the Z 90 degrees to the right, we get the N, but then we have to move it as well. So we rotate it 90 degrees to the left, I mean. So if we rotate it 90 degrees to the left, then we'd have the N, and then we'd also move it, right? We'd just move it over. For the I, look how the I is compared. We just flip it, right? Flip the I. Flip it on its side this way. And then lastly, the P. Look at the P. It's still lined out. All we did was move it from the back to the front. So all we did was move that one. So this is a little introductory to that lesson, little introduction there. And now we're going to define rigid motion. So everything we just did is an example of rigid motion. We did a transformation that did not alter the size or the shape of the pre-image. So in this, all of these are basically called pre-images. Okay, so there's vocab there. Pre-image, how it begins. And then image is how it ends. Okay, so we have a pre-image and an image, and we need to know that. Okay, so that's important vocabulary. So we have pre-image, how it begins, and image, how it ends. So rigid motion, any transformation that does not alter the shape or size of a pre-image. Now the transformations can be translations, what happens when we moved stuff. It's called move, or some people refer to it as slide. Okay, so move or slide. We have reflections, which is when we flipped. And then rotations, when we turn. Okay, so we can slide, flip, and turn. All right, so that's what those means. But we're going to use the academic vocabulary from here on out. All of these are examples of rigid motion. This particular lesson, like I said at the beginning, the particular lesson is all about translations. So we're going to focus in on that. So let's begin. This is what a rigid motion is, right? So hopefully you know how this will work. Here's the first question to ask. We're going to, first things first, identify a rigid motion. So check out this example. Does the transformation below appear to be a rigid motion? Explain. Now remember the definition of rigid motion. A transformation that doesn't alter the size or the shape. Okay, it doesn't alter the size or the shape of the pre-image. So the first example, we had a pre-image here. Here's the image, before, after. Look at it after. It's big. It altered the size. No, right? So, no. Explain, it grew. That's something called a dilation. But that's for later. So anyway, we had the pre-image image. This is not a rigid motion, no. How about this? Pre-image to image. Is it a rigid motion? Yes. All it did was flip. Okay, so that's what we can say. Yes, all it did was flip. It still kept the same size and shape. Okay, so that's how we can identify rigid motion. Cool? Cool. Now, on to this part. What we can do is now name images and their corresponding parts. So take a look at this example. We have a few things. It's going to be a little bit more basic than it might look. We have to, as long as we can read appropriately. So in the diagram, we have E, F, G, H. So here's the shape, E, F, G, H. That's this shape here. We'll do that in blue, and then the way we say that is E prime, F prime, G prime, and H prime. So that's how we say that. E prime, etc. Right? So E prime, F prime, G prime, and H prime. That's how we would say that, right? So that's the image here in red. So what are the images of angle F and angle H? Well, let's first look at angle F. So we have the images of angle F. F is the beginning. What's the new thing? F prime. So it's super simple. F prime is the image of angle F. Actually, I should say angle F prime as the image of angle F. And then what's the image of angle H? Here's H prime. It's that simple, folks. Don't hurt yourself. Now, we say, what are the pairs of corresponding sides, right? So what are the pair of corresponding sides? Well, let's look at first one side. Let's take side EF, right? So if we look at side EF, what is EF going to have an image for? Well, E prime, F prime. That's exactly how simple this is. Don't hurt yourself. Okay, so E prime, F prime. Right? And then we have EF, now we have FG, right? So FG is our pre-image. What's the image of F? So FG, F prime, G prime. That's how easy it is. Okay, so don't hurt yourself. I'll just say dot, dot, dot. You can finish that on your own. Okay, but that's just, I wanted to display how simple that was. Now we have this third question here. It's saying in the diagram, triangle NID, here's NID, translates to, or is the pre-image of triangle SUP, SUP. So NID is the pre-image, and it has the image of SUP. What are the images of angle I and point D? So here's angle I in the beginning, in the pre-image. If this is the post-image, angle I is right there, right? So the image of angle I is actually angle U, no prime at all. Okay, it's just angle U. That's the image. So there's no prime. Notice that. And then the image of point D. Here's point D in the original, in the pre-image. When we move it, it ends up being P. So the image of point D is actually point P. And that's how simple it is to work with what's called rigid motion. So you don't need to hurt yourself, okay? Okay. Pre-images and images. So now, on to some cool stuff. Now we're going to find images of a translation. Take a look at this example here. Okay, so we have an example. What are the vertices of whatever the heck that is? And then we're going to graph the image of triangle PQR. So look at this. What is that? How do you even read that? So I see a capital T and the thing with the things and the arrows. How do you read that? So the first things first, we've got it in the notes. How do you read this? This is read translation. Notice it's T for translation. Okay, so the translation of triangle PQR. Okay, so translation of triangle PQR. Now what's going on here? -2 in the X, and then -5 in the Y. So -2 in the X and -5 in the Y. So that's what this means. And you can, if you read it correctly, you can understand what's happening. So it's the translation of triangle PQR. Here's triangle PQR. And we're going to translate that -2 in the X direction and -5 in the Y direction. So how do we do that? How do we do it? Well, we simply count, right? How do we do this? Count. And then I yell, yeah, just count it. So check this out. We start with point P, let's say, and we're going to move P, -2 in the X, -5 in the Y. -2 is this way in the X, right? So 1, 2, and then -5 in the Y. 1, 2, 3, 4, 5. So the new point P is right there. But note, we have to label the image with our primes. Okay? So if that was the point P we moved, it is now P prime. Okay, we do the same thing with Q. Okay, so we go 2 to the left and 5 down. 2, 3, 4, 5. Here is our new point Q, so we're going to call that Q prime. And then very similarly with R. Okay, 2 to the left, 5 down. And there is our new R. Okay, so we're going to call that R prime. And now we have our triangle. If you want to make it nice and neat, use a straight edge, right? Boom. And boom. And don't be scared to turn a paper. Boom. Remember, in geometry, you don't want to let your head get messed up, so feel free to turn papers. Okay, so that's how we work with images and translations, right? So it's kind of neat how that works. So now, what are we going to do with the next thing? Well, the next thing is kind of interesting. The next thing we're going to learn how to do is write a transformation rule. So this is interesting. Take a look at this question. What is a rule that describes the map that maps PQRS onto P prime, Q prime, R prime, and S prime? Okay, so we have to look at the pre-image and the image. Okay, so here's the pre-image and the image. What's a rule that translates, that maps the original to the image? And so again, how do we do that? We count. Okay, so we're going to count. So let's just focus on the P and P prime, right? So how did we move from P? We went 1, 2, 3, 4, 5, 6, 7, 8 to the right. Okay, 8 to the right, and then 1, 2, 2 down. Okay, but we're not going to accept that. I'm totally not going to accept that as a result because we're going to write a translation rule. Now, a rule is going to be in 2 formats. Okay, there's the format. Remember that crazy capital T format, the translation format, and there's also another format. So I'm giving you a note here. Know both formats. Okay, so the first format is with the capital T that we saw. Okay, and then we had thing whatever's happening in the X and a thing whatever's happening in the Y. That's how we read, a translation, X units to the left or right, and then Y units up or down of the image, okay? Or of the pre-image, excuse me. I should be better with my vocabulary. So we're going to translate a pre-image, either X units to the left or right, or Y units up or down. That's the first format. The other format is called arrow format. It's where you begin with any ordered pair, X and Y, and you draw an arrow, and then you now have X plus or minus a certain number of units, right? So it could be X plus or minus C, and then Y plus or minus C. And so it all depends on whatever you're coming up with, and I'll show you how that works in a second. And so we have those formats, right? And again, so how do we turn 8 to the right and 2 down into these formats? Okay, so this is how. The first format, we'll use the standard, like the really cool stuff with the capital T. So that's what we'll do. We'll have capital T, and then in our little carets there, or whatever you call them, brackets, braces, less than symbol, we're going to first deal with the X. X is left or right. So what happened here? We went 8 units to the right. So all we have to do is fill it in with a positive 8. And then we have the Y. So what happened? It went 2 down. Is down positive or negative? Hopefully you know down is negative. So it'll be 8, negative 2. So what happened is we took the original pre-image and translated it 8 units to the right and 2 units down. But what was the pre-image? Okay, remember we mapped PQRS. So that's what we're doing. PQRS. And that is the first, one of the ways to write a transformation rule. Okay, and we need to know both formats. Okay, so there's that format. So if you see that, don't be afraid. It's just a simple translation. Okay, so a simple translation. Make sure you know translation, the capital T. Okay, and it's going to get tricky as we go through the unit. The other way is arrow format. And so arrow format is also simple if you understand what it's saying. So we have X, Y, and that's how we're going to start it. We're going to start it with X, Y. And it's going to translate into X plus or minus something. Okay, so it's going to be X plus or minus something. So what's happening? We said 8 to the right. That means it's going up, or it's going positive 8. So we would say x plus 8, and then y plus or minus something, right? And look at when we counted, we saw it went 2 down. So it'd be y minus 2. And that is called arrow format. And so we're going to need to know both formats. Okay, just so you can see it. If I throw one way at you, you can catch it. If I throw the other way at you, you can catch that as well. So that is writing a translation rule. Okay, so here's another question, though. Let's see if we know what's going on. So the translation of image triangle LMN, here's triangle LMN, there it is triangle L prime, M prime, N prime, with all these different ordered pairs. What is a coordinate rule that describes the translation? So what we're going to do is plot it and count. We can totally do that. Okay, so we'll say plot and count, and then we'll be all good. Okay, so here's our original L. Where is L prime? It's at 1, negative 2. So L prime is now at 1, negative 2. That's L prime. And then M prime is at 3, negative 4. 1, 2, 3. Oh, it's off the map. It's off the map and down. Oh, no. And then N prime is 6, negative 2. It's off the map. What do we do? Oh, no, right? What do we do? I'm freaking out. And then the answer is, who cares? Because we have all we need. Who cares? We already have L. We're all set, right? We have L. So we have all we need. Okay, so, oh, we're off the map. I don't care. We got what we need. Check it out. If L is going from here to here, L prime, what did it do? We went 1, 2, 3, 4, 5 units to the right. And then we went 1 unit down. Yay. Okay, so 1 down. We have all we need to know. So we went 5 right and 1 down. So how can we write it? In either format, we can write the rule as the big translation of triangle LMN, and then we went 5 units right and 1 unit down. Okay, so look at how that happened as we wrote it. 5 units right and 1 unit down. That's one way. The other way is to use arrow formation. I don't care what you do. So it's 5 units to the right and 1 unit down. Okay? So it's all the same. I don't care which one, but I think you'll end up seeing this format more frequently. So as long as you're comfortable with that. Cool? Cool. Not that bad, right? Hopefully you're thinking, cats, this is easier than I think you're making it out to be. And that's fairly true. So now what we're going to do is learn about a composition of a translation and then call it a day. So we have a diagram at the right, shows 2 moves of a bishop in a chess game. See, a bishop was here, and now it's here. 2 moves. Where now is the bishop in relation to the original position? So the question is, here's where it started, right? It started here, now it's here. Where is it? And so we can use, again, we can use this format. Okay, so what happened? Where is it now? So the bishop started here. It went 1, 2, 3, 4, 5, 6 units to the right and 2 units down. That is actually the answer. Where is the bishop in relation to its original position? There it is. There it is now. Now, what's kind of cool is, how did it get there? Right? So what was the first move? The first move is to here. Okay, so the first move went 1, 2, 3, 4 units to the right and 4 units down. So the first move was 4 units to the right and 4 units down. The second move, okay, the second move went 2 units to the right and 2 units up. The second move went 2 units to the right and 2 units up. And now we're at the final place. Take a look at what's happening though. Final place, add these up. What happens if you add them, right? Boom, boom. 4 plus 2, 6. Negative 4 plus 2, negative 2. So if you just trace your moves, you're going to get to the final translation anyway. And so there's your rule, right? So where is it in relation to the original position? 6 to the right, 2 down. So that's how it works here. And it's the same thing here. In the second question, shows 2 moves of the black bishop, same place. But now it's going to move, the next moves are 3 to the left and 3 down. Where is it in relation to its original position? So we can also count from here. Here's what it is. 3 to the left and 3 down. 1, 2, 3, 1, 2, 3. Here it is now, right? And then what's it in relation to the original position, which was here? So we'd have 1, 2, 3 to the right, and 1, 2, 3, 4, 5 down. And then we can just fill in the rest of the format. That is the answer. Okay, but you can also do it by adding everything up, right, if you remember the previous moves. So that's how composition of translations work. Nothing too crazy. We've done way worse. So now let's end it with a very quick quiz, because some of these questions are cool. I don't know if you can read this, but I'll read it out loud. What's a rule that describes the translation? Okay, so we have an original, pre-image, and the post-image. So what's a rule? A is moving from A to A prime, right? And it's moving 1, 2, 3, 4, 5 to the right, and then 1, 2, 3 down. And that's all it takes, ladies and gentlemen, all it takes. So it was a translation that moved 5 units to the right and 3 down. Super, super easy. Okay, very similar with the second question, right? A rule that describes the translation that maps those. And for this one, we'll use arrow notation. So check this out. Before even counting anything, I can just do this, right? So I don't even have to count anything. I'll just do that. So Q to Q prime. Q goes, let's see, 1, 2, 3, 4, 5, 6 to the right, and 1, 2 down, y minus 2. Ta-da! So there's that rule as well. And we can use either format. Now for the last question. This is juicy. Triangle ABC has vertices at A, B, and C, but here's the translation. We're going to translate it 2 to the left and 3 up. Okay, so the way it reads there, 2 to the left and 3 up. What are the new coordinates? So if A is at 5, 6, A prime is going to be 5, but 2 to the left. 5 minus 2 is 3. And then A was at 6, 3 up is going to be 9. Okay, so 3 up from 6 is 9. B prime started at 6, was going 2 to the left. We are now at 4. And then negative 3, 3 up, negative 3, 3 up is at 0. I love 0. It's such a cool number. And then the last one, C, C prime. C is at 7, down 2 is now at 5. And then C was at 2 for Y, 3 up from Y, positive 5. Ta-da! And there are the new coordinates. So that was a little mini quiz for you and done. So I hope you enjoyed translations. Like I said, I think anyway, simpler than what I probably made of it. So hopefully you enjoyed it. And this is what we had learned, right? So we learned all that cool stuff. Peace out. See you later.